Okay, bit of a precursor. I kind of screwed up today, and my microphone was not plugged in, so this is dubbed after the fact. I didn't realize that I spilled over 1, 2, 3, 4 seconds at the time, but basically I'm trying to get an understanding of this. I also didn't realize that my Excel was pooling so hard into the left at this point. It makes it hard to be able to read the thing. I'll be more conscious of that in the future to make sure Excel doesn't bleed into it. But basically, I'm trying to understand exactly what it's asking. I realized a little bit later that there's actually a really cool equation that'll completely like upend this entire question, and I actually did rebuild it for part 2. I'll actually explain a little bit right now for those who are wondering. So basically, this question takes in 4 times and 4 distances, and you have to see how many different ways can you basically hold onto an accelerator that accelerates at a millimeter per millisecond, and then your thing will coast and reach the end faster than the record. So for 7, you could hold it on for 4 seconds, and then it has 3 seconds to travel 4 centimeters. Cool. However, I noticed that this actually works really easily with difference of squares. You can say, well, if I'm holding for up to 7 seconds, then it means that the peak that I can do would be holding on to 4, letting go for 3, or the other way around. It's a little trickier with odd numbers, but it doesn't really matter because part 2 makes this way easier. And then once you've done that, you can start counting in each direction and saying, well, how far away from the perfect from the perfect square does the destination reach? So basically, if we're dealing with an even number, let's talk about the 30 example here. They have 30 and 200. Half of 30 is 15 seconds, so the optimal would be to hold on to it for 15 seconds. That would give you the furthest distance, or 15 milliseconds. I'm going to say seconds. It doesn't matter. I don't care about milliseconds, millimeters, whatever. But then that gives me 225. The distance is 200. If you do 225 minus 200, you will get the 25, which is the total distance you have in between. What you can do is you can take the square root of that, and that'll give you the distance of squares. Basically, any number that is the product of 2 even numbers that sum to a to one of the value here, like that sum to an even number, can be written as that sum to an even number can be written as the product of, or the difference of 2 squares. So it's a little tricky to look at other examples, but like for example, the number 13 is 1 times 13, which means you can, if you add those together, it gives you 14. Half of that is 7, which means you can say that 13 is a square away from 7 squared. And in this case, that would be 36 away from 49. You could do this with any number, as long as they add up to the destination. In this case, we have our time as the sum number we're comparing against. So we're just trying to find which number is disparate between these here. I didn't do it this way when I'm actually writing it down. What I'm doing is I am trying to create a something that'll just like manually calculate all of these. I did a mistake because I'm not putting in values, which is really annoying. I want to figure out how to like spread the values so that they are actually values. But once I put in the value functions, this ends up working very cleanly with absolutely no issues, actually. I have to actually put in multiple value cases here, which is really annoying, but this should just work, I believe. And then what I just do is I look down and see there's a bunch of zeros, and then I'm just going to do a count of all of these different values to see how many of them break the distance total. I'm making sure I'm understanding what the question's actually asking. So I count that area all the way down to here, and say if that is greater than the distance number, because I'm looking to break the record, not tie the record. And that's it. Bam. I pull that across. I equal the product of that range. And that's the answer. And look at that, I ranked 425th today. I could have done better if I realized that mathy bit earlier. I think I could have saved myself a good, few minutes. But notably, it really isn't that bad. So basically, with the example that I told you, I'm in this case, what I did is I did it manually, and I was doing a binary search manually. I shouldn't have done that because there's a better way of doing it if I had sat and thought about how to do it mathematically. But that's what I ended up doing. So I'm just going to speed through this entire part right now. You're going to see it go acceleration, all the way until eventually I get the number 7723191, which is or 3190 depending, which is this is the lowest number that does still successfully pass. So now I'm trying to finagle with the equation to figure out exactly how to get the range I'm looking for. And this is where I kind of realize, this is calculable, isn't it? But it's a little too late because of how much time I've invested into it. So what you have to do is, since this is the starting point number of distance, what you have to do is you have to take the total, subtract this number -1 twice, and then add 1 in the middle. Because if you imagine there being like a parabola, where this is going to be wrong because I'm actually off by 1. It should be this +1 at the end, because this actually should be 1 lower and then add 1 at the end here. Yeah. So +1. That's all you need to do. The only reason why this didn't work was because I forgot that there's one case right in the exact middle that I'm not accounting for properly. But if I add 1 to it, it ends up working perfectly. I think I'm going to realize that right about now, when I start realizing, shit, I've got to do that +1, because now there's one extra case. The other way you can also calculate that, you're doing that +1 and doing the same thing, and it'll work, and it'll give me the off by 1 error. I feel so dumb, and I've got to wait 15 seconds. 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, and I'm just sitting here making sure that I'm actually totally correct in my answer, and I am. And there you go. Unfortunately, it took me a bit longer than I would have liked. 13:12, not the worst in the world. I've since found a way that took me just under a minute to do part 2. It really did not take very much time at all, and I could just do difference of squares, which trivializes the whole problem. I want to take that equation and put it in the description down below so you can see exactly what I did. Basically, what I put into row 5, column 7, and it just auto solves the whole thing for me. So yeah. Oh, and now you could hear that my mic wasn't plugged in. So yeah, I'm just going to completely remove the audio there, and thank you all for watching. Hope you guys have enjoyed, and I'll see you all next time. Cheers.